This recording is for pre-algebra, chapter 5, lesson 2, comparing and ordering rational numbers and least common multiples, also known as least common denominators. So, well, they're not also known, but they're the similar concept. Okay, I'm not going to do a quote today because I have no idea how long this recording is going to take. All right, a multiple of a number is the product of that number and any non-zero number. So, multiples of 5 would be 5 because 5 times 1 is 5. 10 because 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6, blah, blah, blah. Multiples of 6. 6, 12, 18, 24, 30. Because again, we're multiplying the same number by a bunch of other numbers. So multiples of 5 mean we had to multiply some other number times 5 to get that multiple. Multiples of 6, we had to multiply 6 by some number to get that other number. Okay, so least common multiple, or LCM, is the smallest multiple two or more numbers have in common. So if I'm going to try to find the LCM, there's several ways I can do it. Well, there's actually two. One is to make just a list of the prime factors and multiply them all together, or we can do the upside down cake way, which I prefer, but I'll show you how that works in just a second. So common multiples for 3, 4, and 5 is a whole long list. Okay, so 3, we have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, blah, blah, blah. 4, we have 4, 8, 12, 16, 20. There's a huge long list, and I kind of stopped right there just because it's not worth it. So the best way to do this is actually to find out the prime factors, which using the upside down cake works, but there's no common factors. Since there's no number that go into 3, 4, and 5, basically the LCM is just all the numbers multiplied together. All right? So the LCM for 3, 4, and 5 is actually 60. It is the smallest number that 3, 4, and 5 all go into. Okay? We can divide 60 by 3, 60 by 4, and 60 by 5, and we won't get a remainder. All right? So that's another way to look at LCM, is the smallest number that all of these numbers can be divided into without having a remainder. All right, let's do 9 and 15. And I think I'm going to start making a list. So the list for 9 is 9, 18, 27, 36, 45. For 15, it's 15, 30, and 45. Well, 45 is the smallest number, it's also the first number we get to when we're making our list of multiples that both 9 and 15 have. You can also do it the upside down cake way, which is here. 3 goes into 9 and 15, 3 and 5 times. Now you see when I'm doing the LCM, I actually kind of make an L. When I was doing the greatest common denominator, the greatest common factor, when I was doing the GCF, I would make a G around the 3 because the greatest common factor is 3 for both 9 and 15. But now that I'm doing the LCM, I'm not going to make a G, I'm actually going to make an L shape. All right, so if I was finding the GCF, I'd make a G around the 3, and that would tell me that the greatest common factor is 3 for 9 and 15. But since I'm doing the LCM, I'm going to make an L. See how it's kind of L-shaped? L-shaped. Around the numbers at the bottom of the cake, bottom of the upside down cake, and it's going to be then 3 times 3 times 5, which is 45. All right. All right, LCM for 12, 15, and 18. Well, I'm going to do the upside down cake way because it's much easier to do. 3 goes into both 12, 15, and 18. It goes in 4, 5, and 6 times. Since there's nothing that goes into 4, 5, and 6, I'm going to draw my L, and then I'm going to multiply them all together. 3 times 4 times 5 times 6, 4 times 5 is 20, 3 times 6 is 18, 18 times 20 is 360. So 360 is the LCM for those 3 numbers. Okay? All right, next slide. All right, so again, there's 2 ways to do it. Now, when you have really crazy numbers, like things with letters in it, when you have variables, there's still 2 ways to do it. You can list out all the prime factors and then circle the ones that only happen once.
Mrs. Vice President, please go to student.
Okay, I have no idea where I left off because I've been interrupted like 4 times in the last 5 minutes. All right, so again, you can list out the prime factors, and then you're going to circle what's the same, or excuse me, what happens once for each of the things. You don't circle both. You circle only what happens once. So we had 1, 3, 1, 2, 1, 2, 1, 5, 1 x, and 1 y. So then we're going to multiply them all together, and that's going to give us the LCM for 12x and 15xy. Now that's all fine and dandy, but I personally find this way a little confusing, which is why I use the upside down cake for it. So here's the upside down cake for 12x and 15xy. So what goes into both 12 and 15? Well, that would be 3, leaving us 4x and 5xy, because we're dividing them, right? What goes into both 4x and 5xy? Well, that would be x, leaving us 4 and 5y. Since there's nothing else that goes into 4 and 5y, we're going to draw our L, right? LCM, that's an L. See, it's an L. Colored in. Beautiful. It's an L. And then we're going to multiply everything inside the L together. So it'd be 3 times x times 5 times 4 times y, which when you multiply them all together is 60xy. All right, hold on. Somebody's trying to interrupt me yet again. Okay, back again, hopefully for the rest of the video. Okay, so again, I prefer the upside down cake way. And here's another example. 8m to the second and 14m to the second. If you're doing it long way, you're going to write out the prime factorization, circle what it has the most of. In this case, it has 3 2's as opposed to 1 2, 1 7, and 2 m's. And it doesn't matter which m's you take as long as you only take one set of them. All right, so that would be 2 times 2 times 2 times 7 times m, which would be 56m to the second. And here's the cake way. What goes into m squared and 8m squared and 14m squared would be 2, which leaves you with 4m squared and 7m squared. What goes into 4m squared and 7m squared would be m squared. What's left over? A 4 and a 7. Well, draw your L, multiply everything in the L together, and you're going to get 2 times 4 times 7 times m squared, which is, again, 56m squared. All right. Last example for the upside down cake. What goes into 25y squared and 15x? That would be 5. Nothing else is left over. So draw your L, and you get 5 times y squared times 3 times x is going to give you 25 times 3 times y squared times x, which is 75xy squared. All right. Next slide. Comparing fractions. Remember, negatives are on the left of 0 on a number line, and positives are to the right. And I actually forgot to give you guys another example when I was typing this up. So let me do this one real quick. So if we're to order stuff, we're going to have, let's say we have 4/9 compared to 2/9. Well, which one's bigger? 4/9, right? So it would be 2/9 is smaller than 4/9. What if we had -4/9 and -2/9? Which one's bigger? Well, the smaller, or the one closest to 0, is the biggest one. So -2/9 is larger than -4/9. I should probably box my answers, huh? And then number 3, we have -4/9 compared to +2/9. Well, positives are always bigger than negatives. So there you go. All right. Now, all of those examples had a common denominator of 9. What if they don't have a common denominator? Well, you can find the LCD instead of the LCM. The LCD, it's the same way as finding the LCM. It's just you're finding the common denominator as opposed to the least common multiple. The only thing is, to find the least common denominator, you're going to do it the same way you found the least common multiple. So let's find the LCM for 7 and 5 over here, because we have 6/7 and 4/5. So LCM of that would be 35. Since they're both prime, there's nothing that goes into them other than 1, which means you can't simplify them any before you find the LCM. So it's just 35. So what times 7 is 35? Well, that was 5. So we have to multiply 6 times 5, which is 30. What times 5 is 35? Well, that was 7. So we have to multiply 4 times 7, which is going to give us 28. Well, which one's the bigger one here? Well, that would be 30 over 35 compared to 28 over 35. But we have to use the original numbers, or the original fractions. So the original fractions were that. Since this one's bigger, we then have to use 6/7 is larger or greater than 4/5. All right. Another example, we have 2/3 and 3/4. 3 times 4 is 12. Both of them are prime. The LCM is 12. So what 3 times 4 is 12. So we got to do 2 times 4, which is 8. And 4 times 3 is 12. So 3 times 3 is 9. 9 twelfths is bigger than 8 twelfths. So that means that 3/4 is bigger than 2/3. There you go. Sorry, that's really small. All right, there we go. Okay, so we're gonna use the LCM to help us find the LCD. And again, you also have to use the original numbers like I did in the previous question and to put them in order. So let's go ahead and put these in order. But first we need to find the common denominator using the LCM. So we have to find it for 3, 6, and 12. So 3, 6, and 12, the common denominator is 12 because 3 goes into 12 and 6 goes into 12. 3 times 4 is 12. 6 times 2 is 12. 12 times 1 is 12. So 3 times 4 is 12. So 2 times 4 is 8. 6 times 2 is 12. So 1 times 2 is 2. 5/12 has already got the common denominator, so we don't have to change that. And by the way, BTW, 1 with a common denominator of 12 is equal to 12 over 12 because 12 divided by 12 is 1. So now let's order these from smallest numerator to largest numerator. So the smallest would be 2/12, which is the same as 1/6. 5/12 comes next. 2/3 comes after that because that would have been 8 over 12. And 12 over 12 comes last, which is 1 over 1 because 1 is greater than all of those fractions. These are all less than 1, which means 1 is bigger than all of them. All right, so just a quick recap. You need to make sure that you come up with the common denominator for the 2 denominators or 3 denominators or 4 denominators, depending on how many fractions or numbers you have, and that you write your answer using the original numbers. Because if you don't do that, you're going to get in trouble with me or get in trouble with the textbook because they're asking you to put those numbers in order from least to greatest, even though you have to manipulate those numbers to actually figure out which one is greatest or least. Okay, I believe I am done. There's my little warning, original number. Make sure you write it with the original numbers, and then just make sure you follow directions. So sometimes if they ask, put it from greatest to least to greatest, make sure you read the directions. Okay, that's it. I'm done. Bye. Sorry about all the interruptions, guys.